Hello everyone. I welcome you to ICS Mahesh PU College Dharwad to the Department of Chemistry. Dear students, in our previous class we had understood about the introduction of the solids, states of matter and the general characteristics of solids. So in today's class we shall move further to understand the types of solids, that is crystalline and amorphous solids, and later we are going to understand about the distinguishing properties of crystalline and amorphous solids. This has a weightage of 3 marks in the annual examinations. Let us understand the concepts, dear students. Classification of solids. So dear students, now solids are classified into two types on the basis of nature of order present in the arrangement of constituent particles. I mean, solids are classified based on only the arrangement of constituent particles. The order of arrangement of constituent particles, dear students. Then comes the question, what do you mean by constituent particles? Dear students, solids are made up of particles like atoms, molecules or ions. So these particles are called as constituent particles. So therefore, solids are classified, dear students, based on the arrangement of these constituent particles. If I use the word constituent particles, you need to understand it as atoms or molecules or ions. Later, based on these constituent particles, again there is a classification of crystalline solids. Okay, so they are crystalline solid and amorphous solid. Solids are classified into only two types, dear students, based on the arrangement of constituent particles, that crystalline solids and amorphous solids. Dear students, what is crystalline solid then? They may ask you about crystalline solids for 2 marks, dear students. So the question will be like, define crystalline solid, or what is a crystalline solid? Okay, let us understand. Crystalline solid. A crystalline solid is a type of solid usually consists of a large number of small crystals, each of them having definite characteristics, geometrical shape. So dear students, try to understand the concept. A crystalline solid is a type of solid usually consists of large number of small crystals, each of them having definite characteristic geometric shape. And further I would like to extend the definition. These small crystals are arranged in an definite order. They are arranged perfectly. They are arranged systematically. So therefore, what you need to understand crystalline solids, it means it is a type of solids which are made up of small crystals, and their arrangement or the order of arrangement of these small crystals in a very systematic way. A systematic way in the sense, the way you stand in a row during your assembly. You are standing in a straight line. Boys lines are made separate, girls lines are made separate. So you can see coordination, or you can see the systematic standing of students. Same way, okay, so the particles, the small crystals, okay, they are arranged systematically in the crystalline solids. So what examples can we give, dear students? The examples what we can give is diamonds. Diamond is the best example of crystalline solids. Okay, you can also understand, dear student, if the arrangement is in perfect order, systematic, okay, this can add to the strength or the stiffness of the diamonds, dear students. Metals, salts, etc. Metals, you know, all types of metals. and salts made out of these metals are the example of crystalline solids, dear students. We are going to understand its properties in the next slide. So you can see the images of crystalline solids and amorphous solids. Okay. Next type of solids are called as amorphous solids. These are the type of solids, means amorphous means no form, consist of particles of irregular shape. The arrangement of constituent particles in such a solid has only a short range order. Try to understand, dear students. Make it point wise. These are the type of solids consist of particles of irregular shape. Particles are in irregular shape. This is the first point. Second point is its arrangement. The arrangement of constituent particles is not in a systematic, is not in a perfect way. Okay, in such a solid has only short range order. I would like to add one more point, dear students. Short range order in the sense, if there is a repetition of the arrangement of particles, okay, that can be only seen in a very short short distance. So that is what we call as a short range order. See, try to understand, if at all some sort of systematic arrangement, however, if it is present also, that is not throughout the solid, I can say. It is only a small part of solid, okay, that is called as a short range order. Try to understand, dear students. You have to compare the crystalline and amorphous solids. Okay, in the case of crystalline solids, the particles are of regular shape and the arrangement is systematic. Whereas in the case of amorphous solids, particles are of irregular shape, and however, if there is systematic arrangement is seen in a little part, okay, that is called as a short range order. So this can also add to softness, brittleness to the substance. Okay, unlike in solids, they are very hard. Whereas in the case of, unlike in crystalline solids, they are very hard. In the case of amorphous solids, they are soft. Okay, examples let us understand, like glass, gels, plastics, various polymers, wax, thin films, etc. Okay, so the question that is asked for 3 marks, dear student, like distinguish between crystalline and amorphous solids, or what we can say, write the differences between crystalline and amorphous solids will be the question for 3 marks. So let us understand the points one by one. So okay, so this is the distinguishing properties. So property, crystalline solids and amorphous solids. So this will be asked for 3 marks, dear students. So the first point what you can add is the arrangement. How is the arrangement of constituent particles? In the case of crystalline solids, long range order. Long range order in the sense, the particle arrangement, the systematic arrangement you can see throughout the crystal. This is called long range order. Short range order in the sense, the systematic arrangement is not throughout the crystal, only for a very short distance. Okay, this is one of the point. Arrangement in the case of crystalline solids, long range order. In the case of amorphous solids, short range order. Okay, so next what we can understand, melting point. So crystalline solids, due to the long range order, okay, they have got a sharp melting point. What do you mean by sharp melting point? Crystalline solids melt at a particular temperature. Okay, say for example, the given metal melts, an example, this is an example, a given metal melts at 300 degrees Celsius. Okay, so this is the sharp melting point, dear student. What we can say means it melts at a particular temperature. What about amorphous solids, dear students? Do not have sharp melting point. We can also change this statement as it melts, amorphous solids melt over a range of temperature. Means you cannot give a fixed a melting point to this amorphous solids. You can say the amorphous solid, a given amorphous solids melt between a particular temperature to a particular temperature. Say for example, it can melt between 50 degrees Celsius to 60 degrees Celsius. Means this is the explanation. It do not have a sharp melting point, dear students. Okay, next point, heat of fusion. It has got a definite heat of fusion, and amorphous solids, okay, that do not have a definite heat of fusion. Okay, let us go for the next point, anisotropy and isotropy. So this is a point where they can ask it for 2 marks. Okay, what do you mean by anisotropy and isotropy? Let us understand. Crystalline solids exhibit anisotropic property, whereas amorphous solids exhibit isotropic property. I'll explain this anisotropic property in the next slide. Okay, however, understand, anisotropic means there are some of the physical properties like refractive index, okay, melting point, there are many such properties which when measured, okay, which when measured in different axis, in different direction of a crystalline solid, gives the different values. So this is called anisotropic property, whereas amorphous solids, okay, the physical properties measured in any axis or measured in any direction do not give, okay, it gives a particular or a same values. It gives a same values. That is the meaning of isotropic property. Okay, so we'll understand this point in the next slide again. Nature, okay, they are called true solids. Okay, amorphous solids are called pseudo solids. True solids in the sense they exhibits the properties of all solids. What are the properties of all solids? One of the property which can be used to explain true solids is, okay, the true solids are rigid in nature. They do not flow. The particles do not have the ability to flow. Okay, this is one of the property what we can use to explain true solids for crystalline solids. Whereas amorphous solids, they are called pseudo solids. What do you mean by pseudo solids? Okay, at a particular condition, these solids, okay, they eventually show the flowing nature. The particles show the flowing nature of okay. For example, glass. Dear students, you might have come across the window glasses. The corners of window glasses are bulged. The reason is with time the glass particles, okay, have produced or have shown the property to flow and settled at the corners. Okay, this is not the property of true solids, so therefore they are called as pseudo solids. Okay, so a shape, definite geometrical shape, whereas amorphous solids have irregular shape. They have got, so crystalline solids have definite geometrical shape, whereas amorphous solids cannot be defined with a particular shape, dear students. Okay, so here it is explained, dear students, anisotropy again for 2 marks it is explained. Okay, so anisotropy, crystalline solids are anisotropic in nature. That is, some of their physical properties like electrical resistance or refractive index show different values when measured along different directions in the same crystals. This arises from different arrangement of particles in the different direction. As I told dear students, some of the physical properties like electrical resistance or refractive index, okay, when measured along different directions, say this is one of the direction and this is the other direction. So you can make it out, dear students, when I measure, when it is measured along this direction, you can see same kind of particles are arranged in this particular direction, whereas in this particular direction different particles are arranged in this particular way of direction. So because of this reason, dear student, when physical properties are measured in a different directions, it gives different values. Okay, so This is called anisotropic nature of crystalline solids. Isotropic nature of amorphous solids in the sense, dear students, the particles are already arranged, okay, not in a systematic way, or the what is that, a random arrangement is there, or we can say a short order of arrangement is there. Because of this reason, the amorphous solids behave like that of gases. So therefore, you measure the physical properties in any direction, it gives almost similar values. That is called as isotropic nature of amorphous solids. Okay, so dear students, this is what we have discussed in today's discussion. So in the next coming slide, we are going to understand the classification of crystalline solids, dear students. Thank you for your kind listening.